This video is a companion to exercise 1 for thermal simulations. A reminder, this is not a design class primarily, it's a skills class. You're doing design in Comprehensive Studio. We're learning simulation workflows that you will apply to that design. But today or this week, you are going to design an apartment and a house that you will use in 2 simulations, a daylighting and a thermal simulation exercise. The assumption is that you already know Rhino, and I think that most of, if not all of you, know Rhino better than I do. However, we are using Rhino for simulations in this class, and so it might be helpful for me to go through uh, some features or just some approaches that I find are helpful in this context. First thing, absolutely, you need to set your units to feet. And why is that? It's because we live in the United States and we still use IP units for some reason. So in this class, let's always use IP units unless I say otherwise. So do that first. Secondly, hopefully you're already doing this, but in this class, absolutely you have to create a logical layer tree for everything you're doing. So you see this model that I'm going to be playing with today. I have an architecture set of layers, a thermal and daylighting set. These are for simulations that we're not going to talk about today. But so in my architecture um, layer tree, I have a separate set of house layers and apartment layers, which are very much related because I copied the house layers to make the apartment. Um, So just make sure, and as we go through, the semester, you can ask me more questions about exactly how it makes sense to lay out the layer tree. But it's important that you think this way. If you don't, you will just get lost, and you won't. Remember, the point of simulations is to get information that we can use, and so we need to know what we simulated, right? And we need to be able to turn things on and off really efficiently. All right. Next, what we're um, preparing to do is to have the same essential spatial design in 2 contexts, one a detached house and the other an apartment as part of a multi-apartment unit building. And you'll see why we're doing that. Basically, the context makes a big difference for daylighting and thermal analysis and other simulations that we'll do. So the point is that you need to be thinking about a design. So this is a little house. I'll show you the floor plan in a second. Living room, kitchen, uh, bedroom, bath, and mechanical. Uh, please do not copy this. You can do something similar, but we want to have different designs because we want different outputs so that we can, that's a big part of this class is learning through looking at different outputs for different designs in different situations. But so the point is that we start with a detached house, and then we want a second iteration of that house that can be an apartment in a larger building. So, for example, how do we then change, you know, um, our original house to this apartment? Mainly, we're talking about getting rid of windows, and it has to be a layout that works, right? So you have to think this through ahead of time as you're designing your house, and then it's a pretty simple thing to adjust it so that because this is in my design for this building, that wall that we're just looking at it is onto a corridor. This is the front door, and this is a corridor with to elevators and stairs. Whereas in the house obviously, then we have a front door, and um, this is open to the outside, so it's a different design. Okay, so now let's just talk about how I modeled this, or some basic tips, I guess. Okay, so I'm in my architecture workflow. I've got the apartment turned off. Let's just talk about the plan. We can leave the ground on. If I am going to create a floor plan, and again, you can model this any way you want to, and then adjust it, and I actually want you to do that. The idea is that we have an architectural model that we then use as the baseline for the simulations we're going to create. But you do, the idea is that you're going to be using these simulations moving forward with your career because they're very basic. They're just like drawing, really. So you probably want to develop techniques where it's easy to alter your or to take your architectural design, your model, and turn it into a simulation model. So let's just go over a couple basic things. Like for example, if I were making this plan and I started with a basic footprint and I want to create wall thickness, I'm going to offset. So I'm going to say I'll make the walls a foot thick. And then I'm going to, if I wanted to make this into walls, I'm going to change this. I'm going to make these curves a planar surface. And then I'm going to just extrude the surface to whatever, distance I feels important, that is appropriate. Actually, in this case, since we already have walls, let's just bring it to the same height just to practice that. Now that I've already extruded this, if I use Control Shift, I can select this face and then just extrude it to whatever level I want, and that will adjust my wall. So that's a really good tool to use if you don't know about it already, is Control Shift will allow you to select faces, and then you can just manipulate them. That's really like SketchUp if you've used SketchUp before. So anyway, okay, so next, let's say we want to poke holes, punch holes in this. Now, by the way, we can make this model either with thickened walls or not. Um, that's up to you in terms of how you typically model. In the case of daylighting analysis, it's going to be good to have whatever thickness we think is realistic because then that will create a reveal that will cause shadows and adjust the daylighting so it's more accurate. For thermal modeling, we're just using surfaces, so we would not use the outside. But if I were making a thermal model of this building, for example, I might just come in, and I'm not going to be accurate here, and just create a separate volume, and that's going to be cap. Remember, is the command to make an extrusion of solid, and then that could be a volume I was going to use for my thermal simulation. All right. So anyway, let's say we want to put windows now into these walls, and for daylighting we need to have punched windows, which basically means we need holes, either if it's a surface or a volume, we need to have a hole cut through it in order for light to go through it. That's again going to be different in the thermal simulation, so that's why we're going through these things, is to learn these idiosyncrasies. So how would I poke a hole in this wall easily? One thing that I don't know, this is a great setting. If you go to viewport settings, there's this single viewport mode, and actually let me go turn on my grid. So yeah, now this is right the grid that I'm drawing on. If I go to single viewport mode and let's hit enter. Now whatever viewport I go to, that becomes the drawing plane. And so now if I want to add a window here, I can just come in and draw whatever it is, move it over into the plane of the wall. And now if I can make this into a surface and extrude it. I'm going to cap it. Oh, this is a good chance to use, because I should have done this a different way, but if I, all right, this is actually on a layer, so I'm just going to hide it. If I can come in and do my Control S thing here to select this surface and then extrude it. Maybe I'll combine these. Anyway, so if I show, so now if I do a Boolean difference, between this and this, Now I have my hole, right? And if I were going to do that on a just a surface, so let's say I decided, I was modeling in a different way, and I just had surfaces, not a volume, capping it, then I could draw that window, make it into a surface, and do a Boolean difference. Yeah, there's my hole. So it's pretty easy to do. Another thing you're going to constantly be using when you're doing these models is you're going to need to move similar geometry or the same geometry around and copy and move it. So just remember basics like mirror is super easy and effective. Another one that maybe you guys don't use as much, I don't know, is orient. Same basic idea, but if I now say, okay, I want these 2 points to be oriented this way. Actually, let me redo that. I want this object, these 2 points. Now I'm going to click again on this point 2 and say I want them to be here, those 2 points, and I can reorient it. Of course, I could have copied that instead of just moving it. Okay, so let's go back to our actual house. Um, what else did I do here? I punched holes in these partitions. You're going to need partitions for daylighting. Also, this is you're designing a building. In this case, I added my windows in the middle of my wall. And again, that's just in my mind making this realistic for a window that was be set in. That's going to create a little bit of a shading reveal. Um, and the way I did that is once I had my holes, I'm just drawing surfaces on there and then moving them in some certain amount. By the way, I mean I have polysurface as a shortcut. If you guys don't know how to make shortcuts, I can talk to you about that. They're really helpful. The things that you use often. And by the way, in the gumball, if you guys are not using, for example, like if I can move this in zero point 0.5 feet by hitting the direction I want to go, zero point 0.5, much easier. Now I got to delete this one, I guess. Yeah, see, so I move that in. Actually moved that curve in right there. But another thing I try to do is just clean things up. If I don't need that curve again, I delete it. So I'm often, I'm turning things on and off, seeing what is in that in each layer, just make sure that I'm got things organized in a way that I like. If I have extra curves, I delete them at the points I see them. So now I did the same thing with the doors, set them in. That's completely, if it's an opaque surface in the models we're doing, it's not going to be as important. So whether or not that would be set in or not would be irrelevant here, or pretty much irrelevant. Another thing I mentioned in the assignment is that you want your ceiling to be transparent. That's going to be something you can do next week when you're adjusting your model, but just to realize that if you think about it, we need to have a surface here, but we want to be able to see through it sometimes, like when we're doing a daylighting analysis. So anyway, just that's why that's there, is that's for daylighting. And that can be done either, what I did here is, so that ceiling's on, I made it transparent. So the material is transparent, right? So if I bring it back in, there it is. I'll change it back. Another way you can do this is with the display. So what's that? What is that command? Set object display. Set object display mode. I select it. I can make this have a different um, let's see, so I don't want to use mode view, I'm going to use wireframe. So now the walls can have a different, the exterior walls could have a different display type than the partition walls. A thing that's sometimes difficult to get used to, but you need to learn it and really internalize it, is that the display window, this is a graphic display window. This is not a simulation window. So, in other words, I can have a clear wall and it can still be opaque for the simulation I'm doing, right? So, what you have in the viewport here is not what you're simulating, and you just need to learn the difference. We'll talk about it as we go. For different simulations, it's different. Um, okay, so I'm going to change that back. And so then I modeled a roof that I thought was realistic for. So now this is like an outdoor porch here. This is an entry cover, whatever. I'm not, we're not grading or worried about. I mean, we are worried about design for architects. We always are. But I'm saying that I'm just trying to create something that I can have in two different contexts. Um, so I'm considering this done then as this is my house. Now, how do I make it something that can be an apartment? Well, really all I'm doing, because I thought this through, is if I go back to the other model I was showing you, the more detail where I actually did this. So this is my exterior, I mean my detached house, right? And then I designed a building that has basically that house is an individual unit there's 8 units here on 2 floors. There's a lobby. So I thought it through beforehand that, well, I'm going to have my entrance back here off this corridor. I'm going to have this outdoor space that can be either a balcony or just a porch on a detached house. By closing off this north, in this case, north and east wall, it's not going to affect, it's still going to be a usable space. So, and then how then do I change this model so that I can bring this apartment into a building and do my simulations? The first thing I did was I took whatever layers I needed to take here. So for example, let's say I just want to copy these 2 layers, unless you haven't done this before. Right click on them. If I go to duplicate layers and objects, it just did it. I can now move those wherever I want to, change the names, and I'm good to go. I'm just deleting that. And the interesting thing that I like actually about the Rhino approach, which isn't true of some other programs, is that I can have the identical layer structures or sub-layer structures in 2 different layers. So house can have plan ground, fenestration. Apartment can have fenestration just like house, and it doesn't conflict. So you really can just make them parallel. I didn't bring ground over or plan. Plan of already is the same in my mind, and ground, I'm not going to have a ground over there. Ground is, in this case, is a slab, right? This is a slab on grade. Ground for us is a technical term we'll talk about in our simulations. So how am I going to change this into my apartment? So let me turn off the house, turn on my apartment. Here's, the basics that I had that I'm bringing from the house model. All I need to do now is just go and basically fill in some holes in my case. So how would I do that? Well, I'm back in this, my trusty change my construction plane setting. I'm going to draw a surface here. I already did it, that's what I'm thinking. I did it twice. I'm going to delete one of them. Um, Sometimes I forget that a curve is not a surface. I'm going to turn this into a surface, extrude it. Now I can delete the surface on this side. Oops, no I can't. For some reason I didn't extrude. I wasn't paying attention, I guess. So extrude it. So now I have 2 objects. I'm going to do a Boolean union. Now I should be able to do a merge coplanar faces. Merge all coplanar faces, another really good um, All right, I just had to do a little troubleshooting. Maybe I should do that live, but I'm just trying to make these videos not too long. The Boolean union failed, and the reason what I did is I just exploded this polysurface and rejoined it, and that made it that caused it to work. So there was something glitchy about it. Anyway, so I'm gonna do it again. I'm gonna select these two. So I'm selecting the polysurface that I created here, and the exterior walls, doing a Boolean union, which failed again. That's really funny. Let's try it again. And that works. Failed. Let me just let's do it like this. That one worked. So that's a good point, right? I'm sure you've experienced this in all the programs you use, but sometimes it's not really clear to me what I did wrong. But now I'm going to just delete this extra stuff. I'm going to do a merge coplanar faces. I should be able to, right? So now I've got that one opening closed. I could have done all these at the same time, and so then this wall would have been prepared for the apartment, and then when it's all done and when it's completed. But then in future assignments, we'll then bring that apartment into a building context. Okay, and so now we have. I mean, if I filled in this and this, we would have a completed apartment. It has its fenestration already and partition walls from the other one. And then if we turn the house on, it's the same thing essentially. We have a ceiling that's in place. It's just invisible because for the reasons I said, and I set uh, in my case, I use just a transparency setting. We also have a roof that will be used for, well, this is just a concept right now, and then as we're doing our daylighting studies, we may add overhangs, and we may use this roof as a model for that. Um, okay, so that's it for this. Let's just talk though, make sure we've gone through the whole assignment. And I want to make a couple other comments. Um, First of all, I didn't talk about the program. Make sure you check the program. We don't want this building being too large, so between 900 and 1,500 square feet. There's a specific reason for that, is that we really want to get an understanding of the difference between large and small spaces in terms of the simulations we're going to do. Make sure you're using the separate layers, as I say. We modeled the house, or I showed you how I did it. Walls as envelopes, glazing modeled as single surfaces. I set them in the middle of the envelope. You can put them on the outside or inside, it's up to you. Transparent ceiling layer, overhangs. In our case, I just made it, a roof, and you can add uh, shading as part of your iterations in the daylighting next week. Um, the apartment's the same thing, just adjusted so that it will work in a multi-apartment building. The deliverables, there's no layout for this that I need. Actually, that's wrong. I'm going to go ahead and add um, use class template, because we're supplying templates for these different assignments, uh, to create a simple layout showing your two configurations. All right. Then, so you're going to submit that, a Rhino model, and this is really important. Uh, you have to use this file naming protocol, and I do this every semester, and it's just amazing to me how often people can't do it. It's pretty simple. A413 is the class. EX1 is this exercise. Your last name and first name, and then a description. And actually, in this case, let me change that again too. And it's going to be either model or layout, right? So, you're going to name your model that we just were working on with this file name plus the word model instead of description. And this layout here is going to be the same name, but layout instead of description. By the way, if you think this through, why am I doing this? Because I want this to be in order when I'm reviewing these. This will be, and then when we turn it into atmospheres, we'll have a clear naming protocol. The This can be different. You could make this more descriptive than this if you wanted to, because it doesn't matter. When we get down to this point, it's just we're already in chronological order, which is what I wanted. We're always in our assignments, there'll be a resources section. If there's things I think you should know, I'll try to remember to put them here. So you should check back. Like right now, I'll add this video to this assignment. All right, that's it. I will talk to you soon.